Okay, so let's look at the solution to the first self-assessment question. And we have a simple little problem here of a tank filling up, and there's a flow rate of fluid going into the tank that has a value Q in, and a flow rate coming out that's a value Q out. And we're going to assume that both Q in and Q out are constant, which makes the integration a lot easier than it might be otherwise. So we're also going to do a little bit of tidying up, and you can see that here in the problem I say just define A to be Q in minus Q out. We don't have to do that. It's just a good strategy when you're doing any kind of mathematical work, I think, to try to keep things as uncluttered as possible. And rather than having to keep writing down Q in minus Q out, let's just write it down as A. So let's just go through the integration. So we have dV dt is equal to A, where remember A is equal to Q in minus Q out. So this is just a mass balance essentially. And what we want to do now is integrate this equation. And integration just really means getting rid of the dv and the dt and just having everything just involving v and t, because ultimately we want to be able to do some sort of calculations. And when an equation's in the form of dv dt, you can't actually plug anything in your calculator. So what we're really trying to do now is get rid of these two d's. And the mathematical way you do that is the process of integration. So the first thing you try to do always is to separate the two different kind of d's. So we have a dv up here and a dt down here. So we try to separate those. So the logical way then is just to cross multiply. So we get dv is a times dt. And now we're going to do the integration on that. So we put this s kind of symbol here, and we have going from v0 to v. And then the a, well, we leave the a inside there, it doesn't matter, going from 0 to t. And now we do the integration. So this is really an integration of 1. I mean, that's 1 multiplied by dv. And remember, the integration is the opposite of differentiation, and a dv is just 1. So the integration of 1 is you get the v back. So we get v minus v0 is equal to a, because a is a constant, it just stays out of the integration, t minus t0. And that means that v is equal to v0 plus a times t. I think in the problem statement we said that v0 was 1 liter. So our final answer then is that v is equal to 1 plus a times t. So we have a nice linear increase in volume, because, and that's a direct consequence of the fact that the flow rate, the net flow rate into the tank is you're going to get a nice, so if you were to plot volume versus time here, it starts at 1 and it just goes up like that. And the slope there is equal to A, obviously. Okay, so the second part of the problem then was to use this tool called Wolfram Alpha to solve the same problem. And I suggested that you take this syntax, is what you would call this, and copy it into Wolfram Alpha. I probably have done that already, actually. So Wolfram, here's Wolfram. So here's the syntax. So it says solve v dash of t is equal to a, where the volume at time 0 is equal to 1. Notice this v dash of t equals a. That's v dash is just a slightly different way of writing dv dt. And if you look at the history of calculus, which is obviously what this is, and if you look back to the two people who invented calculus, Isaac Newton and the guy named Leibniz, they both kind of invented calculus, differentiation and integration at the same time, but they used different notation. And I think it was Newton who used this dash notation, whereas Leibniz used the dv dt type notation. So if you just plug this into this fantastic tool, Wolfram Alpha, it actually almost seems like it's intelligent, because this little application can deal with symbols. It doesn't, we always associate computers with being able to churn out loads of numbers and nice fancy graphs and everything, but this will actually work with the symbols. So when we enter that into Wolfram and press enter here, we'll see. So it's asking you to solve dv dt is equal to a with the volume at time 0 to be 1. And there we have the exact same answer as we got by doing it manually ourselves. So that's a very simple problem for Wolfram. It has obviously no problems doing it, but it's a fantastic piece of free software, and hopefully you'll get to use it a bit more over the coming years, because it's certainly a tool that I've learned loads about maths from actually just using it. Lots of new functions I'd never heard of. I've learned about from just trying to solve problems. I really kind of avoid having to do a bunch of algebra myself, and getting Wolfram Alpha to do it. Okay, so that's the solution to the first self-assessment question.